like when we created this components, that is the polymer surfactant, we can see that we have like polymer surfactant Na plus Cl minus. These all like properties are all are added after we have like used the process wizard, where we can see that the molecular weight and the density is there, the viscosity has been added, and other things are there. And obviously, like if we do not want to use the process wizard, we can directly create the model, we can directly create the component, and we can enter these values which we know, and that is another way of adding the component. But the like the benefit of using that process wizard is that when we go in this the raw fluid data, initially what we had was only this interpolation set 1, which you can see. This was the relative permeability curve which we have created. Now, because the process wizard has created three sets, these set 2 and this set 2 and this set 3 is automatically created by the process wizard. Now, if we have to like if we were not using the process wizard and we were like directly adding the surfactant properties, in that case, what has to be done is that we would have to like go to this window which we have used for the creation of the drug fluid type, and like in initial stages this would have been unchecked, and we have to check this and then create the new interpolation set for whatever surfactant we are using. And like the three sets which are automatically created by this, we would have to create the additional second two sets by our own, like we have to manually do that. And other thing is that like after that we would also have to do this thing like the surfactant is actually the changing the relative permeability property of the rock. So we will have to select this interpolation method, interpolation enabled, and we will have to select that okay, based on the properties of the surfactant, we are changing the relative permeability data. This is automatically done because we have used process wizard, but if we would have not used the process wizard, it would have been like we would have to do this manually, and here we would have to like go on and add a new table, and like these values which you see, these are the same values which was there in the that process wizard. These were the values of the surfactant percentage and IFT, and obviously like if we do not have used the process wizard, this we have to do the it where we have to enter this manually. Okay, so that's why we were using the process wizard, and here also like we have different options, like the additional concentration dependent. Like if we are using alkali, then we can enter a second value of IFT values uh, based on the second like alkali concentration. What is the different IFT values of the for the different solvent concentrations? So these all things are there. And here also like after this like the first set we knew that these were the values and we have created using the correlation, and let's assume we want to change the second interpolation set. The third interpolation set will be same, like it is this straight line which is shown. This will always be there, like if we use only two sets of only two uh, sets of relative permeability data, then one of that has to be this straight line curve, and the first one will be the default or the you can say the default values which we gave, or the initial values which we gave. But if we are using this more than two, like three or four interpolation sets, and if we want to change the values, we have to go to this interpolation set 2 at this option, and we will be changing these values. Or again, like we want, if we have a like if we want to use a correlation for the second set, we can use that. But this only will be used if we have the data, and like if we have the exact the exact lateral data for surfactant flooding, like if the entire flooding is done by a surfactant and we use that data to plot the lateral permeability curve, that will be done. But by default, the values which is generated by the CMG, that can also be used. And one of these values and the interpolation of these values are basically used when the surfactant values and the interfacial tension value changes in the modeling. For straight line curve, how we are interpolating? Okay. See, for the straight line, you can we have not entered, but you can see like we have only entered the. I guess you can see only the three values are there, like 0.306, it is 0, and 0.086, 0.9062, which you can see. Like at 0.31, it is 0.90, and the other values are there. So this value, either we will be entering manually, or like these values we have not entered right now. This was already automatically created when we were using the process wizard. Okay, and for interpolation part, like okay, let me just go back to this. Okay, so see, these are like because these are the let's okay, let me just use another curve. So let's say these are the three relative permeability curve for the oil phase, and these are the three sets. So what will happen is that when only water flooding is done, like only when no surfactant is present in the aqueous phase, the this lowermost, or this the default which we have given in the initial stage, this relative permeability curve will be used for the calculation of the flow of fluids. Okay, and when the surfactant is there, like in this condition, like as we have given the like let me show this, these IFT values. So 18 like the highest IFT value is 18.2, and then depending on the surfactant concentration, these IFT values are changing. So what happens is that when the water flooding is going on, it will assume that the IFT is 18.2. But when the surfactant flooding is going, the let's say it reduces from IFT value of 18 to 0.18 or 0.018. What will happen? It will interpolate these values. Like let's say at for saturation at this point we are calculating. So what will do? It will calculate how much value, or which value of IFT has to be, which value of relative permeability curve has to be taken, whether it has to be in between these two or in between these two. Okay, let me explain for, let's say, only for uh, two interpolation curve, that will be a much easier to understand. Okay, before that, let me also show you this thing. Uh, there are there is one term called as interpolation set parameter, which is for the interpolation set 3 is -2, for 1 is -5, and for 2 is -3.5. Okay, and when we use only 2, by default it generates -5 and -2 only for the interpolation parameter -2. And what these actually are, these are actually the capillary number, not capillary, log of capillary number. So okay. So So one of the value was -5 and other value was -2. Okay, so based on the IFT value, the capillary number will change, and based on that capillary number, this log of capillary number changes. So this is actually log of capillary number. So when the water flooding is going on or the IFT is very high, the capillary number will come up near to value. Let's say it will be around minus 6.5, or it will be between lower than -5. So what it will do, it will use this value, or the relative permeability set interpolation set 1. And let's say when we are flooding surfactant, the capillary number changes, the IFT changes, the capillary number changes, and the log of capillary number also changes, and now it is having some value of minus 3.5. Okay, so this 3.5 corresponds to uh, let's say IFT value of 0.01, and this was for 18 point I guess it was 2 or something. So this corresponds to water flooding, and this corresponds to surfactant flooding. So now what happens based on these two parameters, -5 and -2, interpolations, it will interpolate between these two values. Like this will be -2, this will be -5. So like whatever value is there, it will, like if this corresponds to -2, this is -5, so -3.5 will be somewhere here. Like this value will be corresponding to that interpolation. Okay, so when this will be like when the surfactant flooding will be going on, and let's assume it reduces to 0.01, and I'm not saying that it will be -3.5, but let's assume it comes to be -3.5. So this value of KRO will be used when surfactant flooding will be used. And similarly for the water flood, or the for the relative permeability curve of water, similarly the interpolation is done, and it is calculated. Case 3 corresponds to lower IFT. Yes, Amir, the case 3 corresponds to not lowest IFT, it actually corresponds to miscible flooding, or it corresponds to zero IFT. So, like if two phases are completely miscible, this you can say that there is no interface and there is a zero IFT between those two interfaces, and that will lead to the relative permeability curve forming a straight line. Like you can assume, like if two fluids are completely miscible, they will simply there won't be any problem, or there won't be any hindrance when one fluid is present and for the flow of other fluid. Okay, so that in that case, the relative permeability becomes a straight line, and that is actually ideal conditions. Usually, like if water and oil is present, the chances of their complete miscibility is very less. Okay, so this was like the importance of these interpolation parameters and the relative permeability curve. Okay, so we have entered these values. Now the next important step is to include the wells. So for that, the steps are very similar. That we have to add the wells. Like yesterday, like sir added the wells along with their trajectory and their perforations. But in this case, the trajectory of the well is not required, because we are assuming that it is at the core, and water flood will be from one direction and oil production will be from the other direction. Okay, so we will simply create two wells. So we will double click on this wells, and this create new well option will come, and let's add a injector and define it as a injector unwet. We can define it as mob wet also, but that that won't have much effect in this case. And then we can go to our constraints and define the operating constraints. And in this case, I guess the operating constraint will be a flow rate. Let me just go through the tutorial. Yeah, it will be surface water rate at 10 centimeter cube cm3 per hour. Now, as soon as I leave this box, you can see that the CMG has by default uh, changed the value in its SI unit, and it has converted that 10 centimeter cube per hour to its equivalent meter cube per day. And I can click on OK, or I can just go on and create a new well that is a producer by clicking on this add new well option and create a producer well. Define it as producer, and the constant will be, and after going to constant we have to select this constant definition, then only we will get this option. How to know which parameter is constraint? See, like it depends. Like when we are going on the let's say for uh, like for water flooding, we usually know what is the flow rate of water which we are injecting. Like, and when we go for the producer, we usually know at what pressure we are producing. So depending upon that, like we know that which uh, operate or which parameter has to be there. Like in case of core flooding, it is usually the flow rate is maintained, and to maintain the flow rate, we have to select that okay, this is the amount of flow rate. But for producer, in case of the this core flooding, we know that the producer is simply at let's say atmospheric pressure. So we will select that the at that the at the producer is having the pressure of is at atmosphere, or it is at any other pressure which we can define. And similarly, like for reservoir also, we might be like there are different things, like we might be saying that the maximum flow rate has to be 10 barrels per day, so that also we can define. So we already know these values, and after that we are assigning the parameters. Okay, Arunima, is it clear? Okay, so for this I'm keeping the bottom hole pressure as 100 because that's what I know, and click on OK. Okay, so these two wells are made, and okay, one more thing, for injector we have to specify what is the like which fluid we are injecting. So we have to like again double click on injector, and this window will open, and I will go on injected fluid and select that for the at this point the I am injecting 100% water. Like initially for water flooding, I will select that it is 100% water. So mole fraction is being asked. So one mole fraction is injected. I will click on apply and click on OK. So that was the for the injector well. And the next important step is to allocate the position of the well, or to specify where the well is being perforated. So this is very similar to what uh, Vishnu sir have told for in yesterday's class. I will click on this injector, then click on this perf. This window will open. Then I will select the perforations, and I can use this table and manually enter, or I can use this mouse option. So I will click on begin, and this the first cell is selected as the injector. Then I can click on apply, and from here only I can change the well. Again, click on begin and click on the last grid that is used for as a production well. Click on apply. Now in this case, like now in this case, like these in general properties, yesterday I don't think much changes was done, but for the case of core flooding, we have to change this well index type from its default to I think this option. Let me tube and linear flow, and I will specify the radius as 0.002 because the default values that was there at this point as radius 0.07. If you calculate the diameter, you will find that this it will be 0.14 meter, and uh, and the block in which we are perforating, that block has a dimension of 0.09, I guess. It was less than the diameter of the well, so we have to change the radius of this well as well, because if we do not change, it will give error when we will be running, because it will get some absurd values when it will calculate the value, the amount of oil in that and amount of the pore volume in that. So that's why we have changed the radius and we have selected the tube end, and this has to be done for both producer as well as injector. Okay, so now the wells has been allocated and its position has been allocated. Now next is to assign the dates for which we want the results. So now in this, what I will be doing, I will be doing adding the dates by using this range of dates option. So from date will be the very default. Why did we change radius? Okay, let me just cancel this, close this. Okay. Okay, I know that this image does not show the dimension of this block, right? But from as far as I remember, the dimension of this block was, let me just check here. Okay, so the dimension of this block, I have given this value as 0.009. Okay, and when specifying the radius, by default it was showing 0.07. Now if this is the radius, the diameter will be around 0.14. So what I'm saying is that the diameter is around this much, which is not possible. Okay, so that is why we have to change the radius so that the diameter of the well is within this range. So that is why I have given 0.002. So the diameter will become 0.04, and that will be well be in the dimension of this range, this initial. Okay. Okay. So let me just save also. Yeah. So in wells, we have to now add dates. Now for the dates adding, I will use this add range of dates, and the from date will be the initial only, and the to date I will be giving the end date as the initial point from where I will be doing surfactant flooding, and because the surfactant and polymer flooding like this, I'm simulating a experiment which has already been done in the lab. I already know at what point I will start the chemical flooding or surfactant polymer flooding. Okay, so this end date we have to like calculate from minutes to the day, and we have to find out the exact value. And for this, it is around 1.44492. I will click on OK, and for the steps, I will click as hour. I can add minute also, but that will simply give much more data, and that will take much more time to simulate also. So by clicking on OK, I will have created these 32 new dates, and these like corresponds to, I guess, 10 or 5 minutes, something like that. Then again, I will click on this and add a range of dates from, for this now the starting of this will be the end of what previous we have done. So it will be 1 point. Okay, I guess I did a error there, but no issues. 1.44492, and this will be 1.82. The steps I am adding as hours. Okay, and so this range of dates corresponds to the time in which the SP flooding was done, and the last I can again add it for the chase water flooding. Okay, so these dates have been added, and just close it and save again. So during the constraints definition, we have said that only water is being injected from the starting. All the dates consider that water is being flooded for all the time. So we need to change that for the specific time, and we will click on these. No, we will click on the wells, and from here we will basically go to the date for which we want to change the constraint or change uh, the whatever injection we are doing. So we will go to 1.44 that we have added, and it would be like this. Okay, so here we have gone to 1.44 because up to this we have done the water flooding, and then we will go, and here you can see the injector is selected. But if we want to change, say we want to change the production information at this date, we will simply go to this, and we will go to this producer option, and then go to change the date. So like in, let's say, in reservoir, while modeling at a reservoir scale, we want to change the specific parameter for a specific well. We will select that well and then go to the date and change the whatever parameter we want to change. So let's again select the injector and go to that date. This one. So in this I will go to I will see that the injector is selected. The date I have selected is for the injector. Go to constraint definition and again select it. And this has to be done because we are changing some of the parameters. And if we don't do this, we won't be getting the option to change the injected fluid option. And click on apply and then go to injected fluid. And here now we can change the what injection we are doing. Like if we are doing only surfactant flooding, we can change the mole fraction of surfactant. If we are doing only polymer flooding, we will only change the mole fraction of polymer. And if we are doing both surfactant as well as polymer flooding, we will change both. Okay, so like even if we have created the model for surfactant and polymer in later stages, or if we want to inject only one of the component, that is also an option there. So let's change this to, now here I am using some arbitrary values because values which I have is for a previous version, and some values was not matching. So it is, I can give 48 something. For surfactant I can give 0.5. like 1.23 e minus 6 for this, let's say 5.6 e minus 5, and just normalize this. So here we have to take care of the thing that these values are in mole fraction, not the weight percent or ppm. So if we have the values in ppm and weight percent, we have to use our Excel or calculator to convert those amounts to the mole fraction. Then click on apply. So now at this date, from this point, that is 1.44 day, the surfactant polymer flooding will start. And now again, I will, like this injector well is selected, and I will go to another date up to which the surfactant flooding has been done or acid flooding has been done, and we can start the chase water flooding. So it's around, let's say this. We'll go to constraints, click on constraint definition and injected. We will simply enter 0 for polymer, 0 for surfactant, and for water it is 1. So this satisfies that only water flooding has started from that day. So click on apply and OK. And let's save this again. So at up to this point, we have created the model, and now we only have to run this model using the start simulator. So just like in the previous version, there was only 3 options, but in this we have one more. I guess calculate property is a new option for this version. So I will click on stars, and it says if we want to save again, I will click OK. Now here usually like we have the option of like validating the data set or running the data set. Now validating simply means like if we have let's say given some wrong parameter, or let's say we have given some data is missing, so that will come here. Like if we click on validate and run, it will only check for the data set, it will not run the data set, it will only check if any value is missing or if any wording is there, but this step is automatically included when we run. And the second is option is like run to view initialization. Like this option does is, what this option does is it runs for only one time step. So like if any data which we have given wrong, and due to which that the, let's say, the simulation is not going to run, we can find that very easily using this option. This is mostly used in in most of the industries, because they have a very large cells and very large number of cells, and the models are very big. So tightly running that entire model for the entire time is will take more time. So just to check the data, what they do, they run the model for only one time step, and for that this is used. And the other two options are very straightforward, like whether we want to run normally or we want to run in batch. So let's run this immediately and click on run button. Okay, so now we can see that we have got the result, and there is no errors in this. Now to, like, after running like yesterday, I think formed, and we can drag that IRF file to the result and graph and graph 3D, or you can simply click on this launch button. That will also like open the result 3D. But in this 2018 version, like after 2015, the versions which came after 2015, the CMG have introduced another module, you can say, that is a result module, which you can see, which actually combines the capability of both the graph 2D as well as the result which we can see in 3D. So that's not an issue, because if you have older version also, then also you will be getting this IRF file and MRF file. And the only addition is that this is like they have combined this the result viewing option, and we also get a SR3 file now, and this was not earlier created when we were using the previous version. But that's not the issue, and if it's very good that you are able to learn both the versions. So I will simply drag this SR3 file into this result, or I could have also clicked this result option. That would have also like opened the same window which you will be going to see right now. And the only like good thing in this new version is that we have what you can say a templates are already created, which you can simply click on the liquid rate and the oil rate and water rate, and you can see the graph. But in previous version, we have to go on the plot and create the curves, and that also you have learned in yesterday's class. So here you can see that like this for oil rate, initially some oil was being produced, and then it like 100% water cut was being produced. Then when the surfactant flooding was done, there was an increase in oil rate, and then it again reduced after the chase flooding was being done. And here also we can add also the groups and add the curve. Like for that we have to click on this time series, and using this like the lowermost part, this is the curve selector. We can select the well and then select the data source, that is the tutorial 3. Select the well, that is the injector, and then we can go and select the, let's say, cumulative oil, and add to this new plot. Okay, for this I have to select the producer, because for injector there is no cumulative oil. Add curve. Yeah, so this is the cumulative oil curve. So initially, during water flooding phase, it has started to form a plateau, but after surfactant flooding, it again rises and then forms a plateau after the water is being used. And all these curves can also be plotted using the previous versions also. So that's not a issue. And you can also plot the like the cumulative and the oil recovery. And for oil recovery we will select the sectors option. We will select the data source. We will select the entire field in the data, and here we can select the oil recovery factor and add to this. So this will obviously be having a similar kind of curve for the uh, as we have seen for the cumulative oil. And for 3D all, like this also contains a 3D view, which is here. So this is the 3D view, and we can change the date from here, and we can change the property. So like the oil saturation, it is initially 0.69 is the oil saturation. Then we can see that for different dates, the oil saturation is changing. Similarly, for pressure, we can see, and these are all options are also available in the previous version also. I'm just showing what results can be seen. Okay, so this was what the how the SP flooding is done. And again, like after doing this and after history matching, we can again go to wells and change the properties or change the well parameters and see if we are using a different concentration of surfactant polymer, what is the change. And we can compare those results and see how the surfactant flooding on or in the water in the polymer flooding is affecting the oil recovery. Okay, so up to this, anybody have any confusion? Sir, while mentioning date, what changes were made to? Okay, while mentioning the dates, what changes was made during chase water and polymer flooding? See, when I changed the, like when I went to the dates, and what I did was I went selected this constant definition option, and then I went to injected fluid, and I changed these, like in the injected fluid, what will be the component or the composition of those components. Okay, so like if I enter the polymer, that the polymer mole fraction is this much, surfactant mole fraction is this much. So this implies that this much surfactant polymer is being injected as the injection fluid. Okay. Okay. So any other question? So I guess there is no more questions. So I'm just writing my mobile number and the WhatsApp number in this chat. So one of you just ping me, and I will send you the this tutorial file. Okay. Okay. So if there are no more questions, so I think we can end this session. So goodbye and take care.